So question number 87 says, let f and g be continuous functions, and it says that the integral from 2 to 6 of f of x equals 5, the integral from 6 to 2 of g is equal to 7, and you're being asked to find the integral from 2 to 6 of this composite function, this combined function. One thing important to note is that the integral bounds are reversed here and here. So, and we're going to find integral bounds from 2 to 6, so we need to convert this into integral bounds from 2 to 6. Okay, so then when we switch the integral bounds around from 2 to 6, we need to make sure that we sign the area its opposite sign. So when we reverse the bounds of integration, the area is going to be, or the displacement will be its opposite. Okay, so that's the key to this problem. Once we have that, this problem is fairly straightforward in that we are going to then integrate. We can integrate these piece by piece because integrals can be split up. So the constant does not affect integration. And so we're going to integrate the f of x separately from the g of x. And so evaluating this expression, this becomes 3 times the integral of f is 5 plus, when I integrate backwards, or from 2 to 6, the integral of g of x is going to be -7. So then the sum is 15 minus 7, which is 8. So the answer is B. For question number 88, it says f is a twice differentiable function such that the second derivative is less than 0 for all of x. The graph of y equals sx is a secant line passing through the points 3 and f of 3, 5, f of 3, and t is a tangent line to the graph at x equals 4. So we know that this graph must be, this f graph must be a concave down graph. Okay, we don't know if it's increasing or decreasing, but we do know it's concave down. And then we're going to have points at x is 3, and then we'll have points at x equals 5. Okay, so that's generally what it's going to look like. And the secant line we'll draw in red. Okay, so they say they have a secant line. It passes through those points. Okay, so there's my s of x graph. Okay, so the black represents my t, my f. And they also say that there's a tangent line involved here. So it's good to visualize this. This tangent line is going to be at x equals 4. Okay, and it's important to understand that this is not mean value theorem, although it the picture kind of depicts a little bit like mean value theorem. It is not mean value theorem because we don't, that point for the mean value theorem is undetermined, where we know specifically that the tangent line is at 4. So that could be the mean value theorem line. It could be equivalent to s of x. It may or may not be. Okay, so I'm just going to draw it so that's not, just so that we don't overinterpret the information given here. Okay, so the question then asks, which of the following is true? We're looking at some point that is just beyond x equals 4. So we're going to say that x equals 4.2 is just on the right side of this. And it's asking which terms, which line is going to be above the other. So which function is going to be greater at that point? And we can clearly see by the function, by this graph here, just going to do this green is t of x, is going to go t of x is going to be above because of the concavity. Okay? It's going to be above f of x. It's going to be f of x, and the secant line is all because of the concavity. It's going to be below the values of t of f of x. Sorry, below the s of x will always be below the values of f of x, regardless of the position, because of the concavity as well. So it's going to go t greatest s, and then t greatest f, and then s. So it's going to be c. Okay, so it's going to be t greatest, f in the middle, and then s is going to be the lowest point.